Imagine this. It's 2030. A massive dust storm hits Mars. The sky turns dark orange, winds roar past 100 kilometers per hour, and a giant solar power station, the lifeline of a Mars base, starts losing power panel by panel. Output drops by half, then 80%, then almost nothing. NASA faced a similar disaster in 2018 when the Opportunity rover was swallowed by Martian dust and never woke up again. But in 2030, things could be different. This time, Tesla's Optimus robots, the humanoid robots already being tested in Tesla factories, are out in the storm, cleaning solar panels and keeping the power alive. Today, we'll break down how this could work, why it's necessary, and why Martian dust may become one of the biggest threats humans face on Mars. First, let's talk about the real enemy, Martian dust. It sounds harmless, just dirt in the air. But Mars has some of the most extreme dust storms in the solar system. Unlike Earth storms, they can last for weeks or even months. The biggest ones, called global dust storms, can cover the entire planet at once. And that's a huge problem for solar power. Solar panels need sunlight to work, but during major dust storms, thick dust blocks sunlight and can cut power output by up to 70%. Real Mars missions saw panels drop from around 700 watt-hours per day to just 128. Barely enough to keep basic systems alive. Even on clear days, dust slowly builds up on the panels. NASA rover studies found they lose about 0.2% of power every Martian day from dust alone, leading to nearly 10% permanent power loss over several Martian years. This problem has already killed real missions. The Mars Pathfinder, the InSight lander, and most famously, Opportunity. The rover was designed to last 90 days but survived nearly 15 years, until a global dust storm hit Mars in 2018. Its solar panels went dark, the rover lost power, and despite more than 1,000 wake-up attempts, it never responded again. The reason was simple: dust on the solar panels. If humans are ever going to live on Mars, we can't let dust shut everything down again. That's where the robots come in. Now let's talk about the robot. Tesla's Optimus, also known as the Tesla bot, is a humanoid robot built to move like a human, with 2 legs, 2 arms, and hands that can grip, lift, and use tools. In late 2023, Tesla revealed the second-generation Optimus. It was about 5 feet 8 inches tall, weighed around 57 kilograms, could carry 20 kilograms, walk on its own, sort objects, and perform simple factory tasks. By 2025, Optimus robots were already working inside Tesla factories alongside humans. Then, in March 2025, Elon Musk announced that Optimus robots could be sent to Mars aboard SpaceX Starship. The timeline may slip. Getting Starship ready and preparing robots for Mars is extremely difficult, but the goal itself is very real. So why Optimus? Because Mars bases will be designed for humans. The tools, ladders, doors, and equipment will all fit human hands and movement. A humanoid robot can use the same systems without needing everything redesigned for machines. It can climb ladders, carry tools, clean panels, and move across rough terrain. Most importantly, it can work outside in conditions too dangerous for humans. Mars has freezing temperatures, an atmosphere 100 times thinner than Earth's, and high radiation levels. Humans need heavy spacesuits and constant protection to survive there. Robots don't breathe, don't suffer radiation sickness, and can operate much longer outside. For maintaining solar panels on Mars, Optimus may not just be useful, but it could be essential. So what would this actually look like on Mars? Step by step. First comes detection. The Mars base constantly monitors every solar panel. If a dust storm or buildup starts reducing efficiency, the system alerts the AI. Panel array 4B down to 60% output. Maintenance required. Optimus gets the assignment. Next comes preparation. An Optimus robot built for Mars would need major upgrades compared to the factory version on Earth. Martian dust is extremely fine and can slip into tiny gaps. So the robot's joints and electronics would need tight seals, protective coatings, and likely heated internal systems to survive the freezing temperatures. Then comes the dangerous part. During a Martian dust storm, the air can become electrically charged, with massive walls of dust driven by powerful winds. Optimus walks into it anyway. Using AI, sensors, and gyroscopes, the robot balances itself in Mars' low gravity, only 38% of Earth's, while navigating rough terrain and poor visibility. Then, the cleaning begins. Water can't be wasted on Mars, and harsh scrubbing could damage the panels, so the cleaning has to be precise. Optimus could use soft brushes to sweep dust away, or electrostatic systems that repel dust using electric charges. A technology researchers are already developing for Mars missions. Its human-like hands and fine motor control make it ideal for this careful work. Once the panels are cleaned, Optimus returns to the base. Power levels rise again, the lights stay on, life support keeps running, and the mission survives. And during a global dust storm, it may have to repeat that process again and again. Because on Mars, fighting dust is a constant battle. Let's zoom out for a moment. People think the hardest part of Mars is getting there, building a rocket, launching it, land it. But surviving on Mars is the real challenge, and power is at the center of everything. A Mars base depends completely on electricity. Life support, heating, water extraction, communications, food production, and medical systems. Lose power, and the mission fails. Nuclear reactors will likely help power future Mars bases, and NASA is already developing compact reactor systems. But solar power will still be essential, especially in the early stages. The problem is that solar already struggles on Mars. The planet receives only about 43% as much sunlight as Earth because it's farther from the sun. Add massive dust storms and constant dust buildup, and power generation drops fast. That's why Optimus could become far more than a cleaning robot. It could become the system that keeps the entire base alive. Opportunity died in 2018 because no one was there to clear dust from its panels. The rover itself still worked, but without power, it was finished. Now imagine if a single Optimus robot had been there. Walk over, clean the panels, and Opportunity survives. That's the future that engineers are moving toward. An Optimus wouldn't just clean panels. It could repair damaged systems, replace parts, expand solar arrays, and help build the infrastructure that future human settlers will depend on. The robots go first, they prepare Mars, then humans follow. It sounds like science fiction, but it's already beginning. The Optimus robots working inside Tesla factories today could become the early ancestors of the machines that one day keep humans alive on another planet. One robot, one brush, on a planet 140 million miles from Earth. It sounds small, but keeping solar panels clean during a Martian dust storm could be the difference between a mission surviving or failing. Tesla's Optimus wasn't originally built for Mars. It was designed for factories, warehouses, and eventually, everyday life. But sometimes the most important technologies become useful in ways nobody expected. And on Mars, a humanoid robot that can repair, clean, and maintain critical systems might become essential for human survival. If you want more deep dives on the future of Tesla and space exploration, subscribe and turn on notifications. And let me know in the comments, do you think Optimus will reach Mars within the next 5 years? See you in the next one.